Silver nitrate is an inorganic compound with chemical formula AgNO, 3. This compound is a versatile precursor to many other silver compounds, such as those used in photography. It is far less sensitive to light than the halides. It was once called lunar caustic because silver was called lunar by the ancient alchemists, who believed that silver was associated with the moon. In solid silver nitrate, the silver ions are 3-coordinated in a trigonal planar arrangement. Discovery: Albertus Magnus, in the 13th century, documented the ability of nitric acid to separate gold and silver by dissolving the silver. Magnus noted that the resulting solution of silver nitrate could blacken skin. Its common name at the time was nitric acid silver. Synthesis: silver nitrate can be prepared by reacting silver, such as a silver bullion or silver foil, with nitric acid, resulting in silver nitrate, water, and oxides of nitrogen. Reaction byproducts depend upon the concentration of nitric acid used. 3Ag plus 4HNO3 or 3AgNO3 plus 2 hours 2O plus NO, Ag plus 2HNO3 or AgNO3 plus H2O plus NO2. This is performed under a fume hood because of toxic nitrogen oxide, S, evolved during the reaction. Reactions: a typical reaction with silver nitrate is to suspend a rod of copper in a solution of silver nitrate and leave it for a few hours. The silver nitrate reacts with copper to form hair-like crystals of silver metal and a blue solution of copper nitrate, 2AgNO3 plus cubic Ag2, NO3, 2 plus 2Ag. Silver nitrate decomposes when heated, 2AgNO3, L, A2Ag, S, plus O2, G, plus 2NO2, G. Qualitatively, decomposition is negligible below the melting point, but becomes appreciable around 250 degrees Celsius and totally decompose at 440 degrees Celsius. Most metal nitrates thermally decompose to the respective oxides, but silver oxide decomposes at a lower temperature than silver nitrate, so the decomposition of silver nitrate yields elemental silver instead. Uses: precursor to other silver compounds, silver nitrate is the least expensive salt of silver. It offers several other advantages as well. It is non-hygroscopic, in contrast to silver fluoroborate and silver perchlorate. It is relatively stable to light. Finally, it dissolves in numerous solvents, including water. The nitrate can be easily replaced by other ligands, rendering AgNO3 versatile. Treatment with solutions of halide ions gives a precipitate of AgX. When making photographic film, silver nitrate is treated with halide salts of sodium or potassium to form insoluble silver halide in situ in photographic gelatin, which is then applied to strips of triacetate or polyester. Similarly, silver nitrate is used to prepare some silver-based explosives, such as the fulminate, azide, or acetylide, through a precipitation reaction. Treatment of silver nitrate with base gives dark gray silver oxide, 2AgNO3 plus 2NaO Ag2O plus 2NaNO3 plus H2O, halide abstraction. The silver cation, Ag+, reacts quickly with halide sources to produce the insoluble silver halide, which is a cream precipitate if Br is used, a white precipitate if Cl is used and a yellow precipitate if Ea is used. This reaction is commonly used in inorganic chemistry to abstract halides, Ag++ Zab, Ag, and AgX, where Za equals Cl, Bra, or Ea. Other silver salts with non-coordinating anions, namely silver tetrafluoroborate and silver hexafluorophosphate, are used for more demanding applications. Similarly, this reaction is used in analytical chemistry to confirm the presence of chloride, bromide, or iodide. Ions can be tested by adding silver nitrate solution. Samples are typically acidified with dilute nitric acid to remove interfering ions, for example carbonate ions and sulfide ions. This step avoids confusion of silver sulfide or silver carbonate precipitates with that of silver halides. The color of precipitate varies with the halide: white, pale yellow, cream, yellow. AgBr and especially Ag photo-decompose to the metal, as evidenced by a grayish color on exposed samples. Organic synthesis: silver nitrate is used in many ways in organic synthesis, for example for depth protection and oxidations. Ag+ binds alkanes reversibly, and silver nitrate has been used to separate mixtures of alkanes by selective absorption. The resulting adduct can be decomposed with ammonia to release the free alkane. Biology. In histology, silver nitrate is used for silver staining, for demonstrating reticular fibers, proteins and nucleic acids. For this reason it is also used to demonstrate proteins in page gels. It can be used as a stain in scanning electron microscopy. Medicine. Silver salts have antiseptic properties. Until the development and widespread adoption of antibiotics, dilute solutions of AgNO used to be dropped into newborn babies' eyes at birth to prevent contraction of gonorrhea from the mother. Eye infections and blindness of newborns was reduced by this method. Incorrect dosage, however, could cause blindness in extreme cases. This protection was first used by Creda copyright in 1881. Fused silver nitrate, shaped into sticks, was traditionally called lunar caustic. It is used as a cauterizing agent, for example to remove granulation tissue around a stoma. General Sir James Abbott noted in his journals that in India in 1827 it was infused by a British surgeon into wounds in his arm resulting from the bite of a mad dog to cauterize the wounds and prevent the onset of rabies. Dentists sometimes use silver nitrate-infused swabs to heal oral ulcers. Silver nitrate is also used by some podiatrists to kill cells located in the nail bed. Silver nitrate is also used to cauterize superficial blood vessels in the nose to help prevent nosebleeds. The Canadian physician C.A. Douglas Ringrose researched the use of silver nitrate for sterilization procedures on women. A specialist in obstetrics and gynecology, Ringrose believed that the corrosive properties of silver nitrate could be used to block and corrode the fallopian tubes, in a process that he called office tubal sterilization. The technique was ineffective. In fact, at least 2 women underwent abortions. Ringrose was sued for malpractice, although these suits were unsuccessful. Disinfection. Much research has been done in evaluating the ability of the silver ion at inactivating Escherichia coli, a microorganism commonly used as an indicator for fecal contamination and as a surrogate for pathogens in drinking water treatment. Concentrations of silver nitrate evaluated in an activation experiment range from 10 to 200 micrograms per liter as Ag+. Silver's antimicrobial activity saw many applications prior to the discovery of modern antibiotics, when it fell into near disuse. Its association with argyria made consumers wary and led them to turn away from it when given an alternative. Against warts. Repeated daily application of silver nitrate can induce adequate destruction of cutaneous warts, but occasionally pigmented scars may develop. In a placebo-controlled study of 70 patients, silver nitrate given over 9 days resulted in clearance of all warts in 43% and improvement in warts in 26% 1 month after treatment compared to 11% and 14%, respectively, in the placebo group. Safety. As an oxidant, silver nitrate should be properly stored away from organic compounds. Despite its common usage in extremely low concentrations to prevent gonorrhea and control nosebleeds, silver nitrate is still very much toxic and corrosive. Brief exposure will not produce any immediate side effects other than the purple, brown or black stains on the skin, but upon constant exposure to high concentrations, side effects will be noticeable, which include burns. Long-term exposure may cause eye damage. Silver nitrate is known to be a skin and eye irritant. Silver nitrate is currently unregulated in water sources by the Environmental Protection Agency. However, if more than 1 gram of silver is accumulated in the body, a condition called argyria may develop. Argyria is a permanent cosmetic condition in which the skin and internal organs turn a blue-gray color. The United States Environmental Protection Agency used to have a maximum contaminant limit for silver in water until 1990, when it was determined that argyria did not impact the function of any affected organs. Argyria is more often associated with the consumption of colloidal silver solutions rather than with silver nitrate, since it is only used at extremely low concentrations to disinfect the water. However, it is still important to be wary before ingesting any sort of silver ion solution. References. External links. International Chemical Safety Card 1116, NIOSH Pocket Guide to Chemical Hazards.